Hello students. So today we are discussing about the what are the collisions, explain the possible types of collisions, develop the theory of one dimensional elastic collision, the relative velocity of approach of two colliding bodies before collision is equals to the relative velocity of separation after collision, and find the final velocities. Okay students, now we go for the answer of this collision. See here in these collisions, okay, definition of collision we have to write first: the strong interaction between two bodies with or without contact is known as collisions. Now, strong interaction with or without contact. So without contact, okay, that means with contact is collision is nothing but colliding with each other. Without contact collision is, like best example is magnetic opposite poles, magnetic like poles, and another example is collision occurred without contact in nucleus. Okay, so without contact in atom also we can take. So the strong interaction between two bodies with or without contact is known as collision. Now, types of collision. So elastic collision. In the collision, both momentum and kinetic energy are conserved. Is called elastic collision. Example: billiard balls, etc. In elastic collision, in this collision only momentum is conserved but not kinetic energy, is called as inelastic collision. Best example is when two cars met with an accident, etc. etc. You can write here. So one dimensional elastic collision. According to question we have to go there. Firstly we have written collision, and then we have written types of collision, and then we are going for develop the theory of one dimensional elastic collision. So this is the one dimensional elastic collision. That means one dimension means linear motion. So in linear motion, the collision occurred between these two bodies mass m1 and m2 having initial velocities u1 and u2. During collision, it will again gains another velocities. Those are known as final velocities v1 and v2. And the same thing will be occurred here, that is both momentum and kinetic energy are conserved here. So masses are m1 and m2. That means here we are supposing it that masses m1 m2 are moving in a linear motion with a linear velocities u1 and u2 before collision in a straight line motion. After collision, these bodies acquires velocities v1 and v2 as shown in figure. So this is the diagram: before collision, during collision, after collision. Here both momentum and kinetic energy are conserved. Both momentum and kinetic energy are conserved. So law of conservation of momentum. So now conservation has been occurred in momentum and kinetic energy. So I am writing here law of conservation of momentum, which is nothing but sum of the initial momentums is equals to sum of the final momentums. That is nothing but pi is equals to pf. Now m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. Now we will shift this m1 v1 to this side. That means we are taking m1 at one side, m2 at another side. So m1 u1, here already m1 u1 is there, so we have kept it same, but m2 u2 has been shifted to this side. Plus will be changed, the sign will be changed here from plus to minus m2 u2. Here the plus m1 v1 will be changed here, as sign will be changed as minus m1 v1. So now by taking common from m1 u1 and m1 v1, m1 is common. Now the remaining term will be written as u1 minus v1 is equals to m2 into v2 minus u2. This is your equation number 1, which has been occurred from law of conservation of momentum. Now again we go for law of conservation of kinetic energy. Law of conservation of kinetic energy. Same similar thing. Kinetic energy initial is there. This is the I initial is equals to KEF. That is kinetic energy final. That is kinetic energy final. Now kinetic energy formula is half mv square. So we have written here for first object initial velocity is u1 square, half m1 u1 square plus half m2 u2 square is equals to half m1 v1 square plus half m2 v2 square. Now each and every half will be cancelled, because by taking half from these two terms common also we can cancel it, otherwise we can cancel directly. Now remaining term written as m1 u1 square plus m2 u2 square is equals to m1 v1 square plus m2 v2 square. Now same thing again repeated here, mass m1 will be sent to this side, mass m2 will be sent to this side. That means we will take mass m1 at one side, m2 at another side. So now m1 u1 square, this will come here minus m1 v square, and this will goes there m2 v2 square minus m2 u2 square. So now taking common terms, mass m1 common here, then u1 square minus v1 square is equals to m2 into v2 square minus u2 square. Now see here, a square minus b square is their formula. So a minus b into a plus b. So m1 into u1 minus v1 into u1 plus v1 is equals to m2 into same thing here also, a square minus b square formula, a minus b into a plus b, v2 minus u2 into v2 plus u2, equation number 2. This is our equation number 2. Now dividing 2 and 1. Now dividing 2 and 1. So m1 u1 minus v1 u1 plus v1 divided by m1 u1 minus v1 is equals to m2 v2 minus u2 into v2 plus u2 divided by m2 into v2 minus u2. m2 into v2 minus u2, m2 into v2 minus u2 cancel, m1 into u1 minus v1, m1 into u1 minus v1 cancel. The remaining term will be u1 plus v1 is equals to v2 plus u2. Now initial velocities, we will take initial velocities at one end and one hand side, and another hand side we will have final velocities. So plus u2 will come here, minus u2, plus v1 we will be here minus v1. So u1 minus u2 is equals to v2 minus v1. This is our equation number 3. This represents that the relative velocity of approach of two colliding bodies before collision are equal to the relative velocities of separation after collision. Now at last we have to find the velocity, final velocities. To find v1 from equation 3, v2 is equals to u1 minus u2 plus v1. Substitute in equation number 1. So then v1 is equals to m1 minus m2 divided by m1 plus m2 into u1 plus 2m2 divided by m1 plus m2 into u2, equation number 4. Now to find v2, that is from equation 3, here from equation this 3 we are writing v1 is equals to v2 minus u1 plus u2. Substitute equation number 1. Then v2 is equals to 2m1 by m1 plus m2 into u1 plus m2 minus m1 by m1 plus m2 into u2, equation number 5. This 4 and 5 equation represent the final velocities after collision. You see, to find v1 you have to neglect the value. That means you have to write the value of v2 in terms of u1, u2 and v1. If you are finding v2, then you have to write the v1 value in terms of v2, u1 and u2. Okay. So for getting this total value, I will give you another video regarding this. This is only for exam point of view. So that's why I have taken only exam point of view points only. If you write this total correctly, then you will get 8 marks. Okay. Okay students, for to finding v1, to finding v2, we will have another video regarding this, because to know about this for only for understanding purpose. Okay. Thank you students. Just take a screenshot of this. Once again I will show you the total question. Okay. I think okay, this one, then continuation part is here. Okay students, bye students.